This is a quick walkthrough of modeling the 3D parts in Submission 1, and also a few tips and tricks on how to place the dimensions in a very easily readable way. I'll start off with creating the lower part of the machine component. So a circle with a diameter of 40. A rectangle that is 40 and 50 plus 10. And also I need to lock the rectangle to the center point here. So now everything is fully constrained. I finish my sketch, click extrude, and I mark both sections here. Click OK. I create a new sketch, place it on top of the old one. I'll do some project geometry just to get the circle locked into place, like this. Then I extrude it. So now I've got the basic shape of it. I'm going to do fillets to the edges here, just to get those rounded. And now I can start creating the holes. So I use the hole function. I use the concentric one option. I click on this plane and this concentric reference, and I set it to 30 millimeters. Click apply. I choose this plane. And now I just have to put it back to 10. And I choose this concentric reference. I click apply. Then again choose this plane and this concentric reference, and then I can click OK. And that's everything for creating the 3D parts. And it didn't say anything about material in the task, but then you just choose some material that you want it to be. Some were very creative in their choices, and that's completely fine. I had not specified anything in the part. I'm choosing stainless steel for this one. And then I go into a drawing. So I'm going to place the base view here. So I want to look at it from the top. And I rotate it, putting it in at 2:1, because if you look at 3:1, it's going to be a bit cramped putting that one in. So I'm putting it in at 2:1. Now one way of doing this is to show hidden lines and placing a projected view up here, because the hidden lines now are going to show that the 30 millimeter hole and the two 10 millimeter holes are going straight through the machine component. So that is an okay enough way of doing it, but you want to be careful when you're using hidden lines, because it can quickly become a very cluttered drawing with it. Another option is to remove the hidden lines. And in this case we'll remove the projected view also, because we're going to show a section view. Now if I put a regular section view straight through the component like this, I'm not going to be able to show the 10 millimeter holes, only the 30 millimeter hole. So if I instead stop halfway between here, and I get up to this point where it locks onto the center of the 10 millimeter, and then I continue out to the side. Then my projected view, my section view, is going to show both the 30 millimeter hole and one of the 10 millimeter holes, and it's going to show that they're going straight through. So that's a viable option for doing this and getting to show it properly. But another option that is possible to use is to just let the projected view without the hidden lines stay there, and then instead use the hole and thread function on the holes. So method 1b for ISO, and it says through there. I will do the same here. It says through, and if I also edit this one and I place a quantity note in front of it, however I create these two holes individually. So I need to edit the quantity note and set it to count the number of like holes in this view. Then it's going to say 2 times 10 millimeters and all the way through. So that's a very clean way of doing this and getting to show it properly. I can also simplify this radius by setting tip behind it. So it's going to count for the other side here also. I also wanted to be very clear that this is a diameter, so I need to have the diametrical mark on top of this one. But it is possible to pull it to the outside and get it to show properly, as if it was a height dimension. One more thing to do is to use your center marks appropriately. So in this case, you want the center mark to extend past the 40 millimeter diameter. And also for these holes, you would like to add the R10s on the outsides. This makes it very clear that if I set the dimension from the center of this hole to the center of this hole, then the R10 is going to start directly afterwards, since they are sharing the center point. This means that the only length dimension I need to give horizontally here is this 50 millimeters between the centers of the holes. I can do the same by extending the center line here, and then I can give it a dimension only between the center points, because now I've shown that the top half and the lower half are symmetrical. Up on this one, it is possible to give the dimension over here, but as you're going to see, this dimension line can make the drawing quite cluttered and a bit difficult to read. So we're not going to place that one there. Instead, we're going to do the full height, total height on this side, and then we'll do half the height on this side. Now, depending on your point of view, some would prefer not to have any center lines going through here, even though the top half here is completely cylindrical. They would just feel that since the rest of this machine component isn't cylindrical, it is not necessary to have a center line there. Some feel that it would be correct to have a center line going through the part that is actually cylindrical. And some would prefer to actually pull the center line all the way through, just to symbolize that there is a hole going through here. But if you're going to use a center line here to show that there's a hole going through, you have to do the same for these holes. So this is not really a good option. So at the maximum, I would recommend using the half center line to show that the top part here is cylindrical, or just keep it off completely. Now, I set the material for the 3D part, which means that I should show the material over in the corner here. And I didn't mention the material, and I didn't mention general tolerances or general surface finish either, and I didn't mention anything about notes. So what you should do in such a case is to assume something. So this looks to be a part that isn't really necessary to have it very, very accurate. So a medium tolerance should be enough. So you would then guess on a medium tolerance, and you would place the medium tolerance note up here for general tolerances. Now, in a work situation, if that was a bad judgment call in putting it as a medium, if it needed to be fine instead, then your checker and approver should notice and tell you that this is not going to work, we need to use the fine tolerances, you have to fix that. The same goes for the surface finish, which we usually have in the middle here. And in this case, you almost definitely have to mill this part. And then you would go into your Metal Trades handbook and look at the surface roughness tables and look at what is a mid-range surface roughness if you're using a milling machine. And then you would choose that one. Again, if your guess would be incorrect, your checker and approver should notice and tell you so. Also with the notes, it is always good to add a note with break sharp edges, just because then you actually have it. And also you have already established a section on your technical drawing for notes, which means that if you at a later date are going to revise the drawing, it might be necessary to add some text to explain why or even how stuff have been changed. And then your notes are already there, so they are easy to find. That was all for this one. Your individual comments will be uploaded to Fronter as soon as I am finished correcting them.